So Sabina wants to know how long it takes students to get to school. She asked two students how long it takes them to get to school. It takes one student 1 minute and the other student 11 minutes. Sabina represents these data values on a ruler, putting a penny, we're not using pennies, we're using the cubes, at 1 inch and the other at 11 inches. Sabina thinks there might be a connection between the mean of the two data points and where they balance on a ruler. She thinks the mean may be the balancing point. She shows her data using a dot plot. So if we were to draw a dot plot real quick, everybody, what's the first thing to do to draw a dot plot? Draw a line. Yep, it started with 1, the biggest one was 11. And of course, we know with the ruler, we got 0 and it goes up to 12. We'll go and do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me scoot this over just a little bit. 11, 12. So she's thinking that the balance point is going to be right at 3, 4, 5, 6. About halfway in between. What do you guys say that 6 looks halfway between 1 and 11? Okay, when you guys are taping these, try to make sure that the center is right about over top middle of the value. So she thinks there's a connection between the two. So if you guys have your, well, first off, she says, okay, let's go ahead and compare and see if this is a balance point. So take your finger, put it underneath the 6, and let's see if it balances. Is it fairly well balanced? Or does it fall to one side or the other? Tim did a really great job with his. Who else is getting it to balance? Jamalith? All right. It's kind of hard to get it to tape just right, but as long as you get it close enough, that's a pretty good indicator. All right. Now, what if you move your finger to the 7? Will it still be balanced? No, it'll clearly fall one way. Try moving your finger to the 4. It'll definitely fall to the other way. So the mean, what is the mean between 1 and 11? How do we find the mean between two numbers? Okay, so what is 1 plus 11? That's 12. Then how many values did we have?
2.
Yeah, we just had 1, 2 values. So 12 divided by 2 will be equal to 6. And hey, my mean, 6 is the mean. And that's also a balance point. And yes, it is the median. If there are only two numbers and they're not the same, you have to add them together, divide by 2. And yes, this does also happen to be the median. Now I'm going to ask you guys a question. What if I moved both of these cubes in by 3? So 1 plus 3 is 4, right?
Yeah.
What is 11 minus 3?
8.
Okay, so I'm moving it towards the center an equal amount each time. I'm going in by 3 each. There we go. Where do I think my new mean is going to be?
9, 8.
Just look at it. Where do you think this will balance? Do you think it'll balance at the 9?
6.
You think it'll balance at the 6?
No.
Let's see. Will it balance? I'd say that's my balance point. I'm having trouble getting it to balance because of my cubes. There we go. Yes, the 6 does appear to be the new balance point. What is 8 plus 4?
12.
Oh, okay. So I'm going to have my same total. Did I add any more numbers? So if I divide by 2, what's my mean still going to be? What's my mean still going to be? What's 12 divided by 2? Oh, okay. So what do you guys think? Will this always work?
Yeah.
Some people say yes. Are we actually practicing with this? Are we writing it down? So Sabina thinks that if two data points move the same distance but in opposite directions, the balancing point on the ruler does not change. Do you guys agree with that? As long as you change each one by the same amount, is the balance point going to change?
No.
Well, I mean, let's think about it. I move them in opposite directions. I moved the lower one up and I moved the higher value down, but I moved them by the same amount. I both moved them by a value of 3. Did my balance point change? It was 6, and then it was also 6. So did that change? Louis says no. Okay. So to keep the ruler balanced at 6 inches, how far should Sabina move the penny from 8 inches? And in what direction? No, hold on. I'm sorry. I missed one part. It says Sabina.
Excuse me, teachers, just a reminder for you to get your lunch count and attendance in.
So it says Sabina continues moving the penny at 4 inches to 6 inches. So if she moved it from 4 to 6, where does the penny at 8 have to move to keep the same balance point? Some people are saying the 6. So if I keep them both stacked at 6, will my balance point remain at 6?
Yeah, no.
Well, yes, if I was better at balancing. Then if they were both at 6, is it going to be weighted one way or the other? Not really. Again, I'm just not that good at balancing. But if everything is at 6, let's prove it mathematically. What's 6? Everyone on your papers, if you're not doing this, if I had 2 points at 6, what's 6 plus 6? Does this look familiar now? How many points do I have? So what's 12 divided by 2? So what's my new mean? So did it change? No. All right, so now it's your turn to try balancing 2 pennies on a ruler. I want you to tape 1 penny at 2.5 inches on the ruler. Where should the second penny be taped so that the ruler will balance at 6 inches? Again, tape 1 penny at 2.5 inches. Where should the next penny be balanced? You guys try doing that now. All right, with your tape.